Section 11.1 is where we're going to talk about space figures and cross sections. So a space figure is really just a three-dimensional figure. So we're going to be talking about prisms, cylinders, pyramids, cones throughout this unit. So the first one is a polyhedron, and that's when all of the surfaces are polygons. So that means that it would not involve any types of circles. Each polygon is a face of the polyhedron. So here I'm showing you that these are all of your faces. Your edges are where your faces connect and form that edge, and then a vertex is the corner of one of your points. So it says a point where three or more edges are intersecting. So the first part is just understanding that vocab and making sure that you can list them out. So it says how many vertices, edges, faces are in the polyhedron at the right. List them. So vertices, again, would be where all of your corners are. So I would have 5 of those. So if I listed it, it would just be points. So I listed D, E, F, G, and H. Your edges are where my faces intersect or where they connect. So you would have 8 of those. So 1, 2, 3, 4. 1, 2, 3, 4. So then I just listed all those line segments. So D, E, E, F, F, G, G, D. And then I went D, H, E, H, F, H, G, H. And then for your faces, those are the sides of your polyhedron. So remember, those are going to be actual figures. So I have 5 faces because I've got 4 triangles and then a square on the bottom. So I have triangle DEH, triangle EFH, triangle FGH, triangle DGH, and then last I would have this rectangle or parallelogram, so I just listed DGFE. That should be DGFE. So on these, you're just kind of practicing making sure you know what that vocab is. So I would like for you to pause the video and try the next one. So in the got it question, we have the same thing, wanting you to identify the vertices, edges, and faces. So I would have 6 vertices, R, S, T, U, V, and W. For the edges, you should have 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have RU, RS, ST, TU. Then I went UV, VW, WT, TU, and then RV and SW. And then for your faces, you would have 2 triangles on the front and the back. You'd have a rectangle back here, rectangle on the bottom, rectangle on the front, so you would have 5. So I had triangle RUV, triangle STW, and then I just wrote them out as quadrilaterals, so RUTS, TUVW, and then RSWV. Okay, so that's your vocab for the polyhedrons. Next thing is we're going to be using Euler's formula, and this was a guy who did some mathematics throughout, and he came up with this formula that it said if you add the number of faces with the number of vertices, that should be equal to 2 plus the number of edges. So you can always verify if you have the correct numbers. So this next problem is where we're just going to practice using Euler's number, or Euler's formula. So up at the top here you see that we have another polyhedron. It says how many vertices, edges, faces do you have, and then verify using Euler's number. So first thing I did was just go ahead and list out how many of each that I have. So I counted 12 vertices, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I had 18 edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and then 8 faces, 1, 2, 3, 4, 5, 6, 7, 8. So what you're going to do is use Euler's formula, which says add these two together, and that'll be equal to the edges plus 2. Hello? No. Thank you. Bye. Okay. Sorry for that. Interruption with a phone call. So we're going to add our faces and vertices. So I'm going to add 8 and 12, and then I'm going to add my edges, which is 18, and add 2 to that. In order for this to verify, I need to get the same number on both sides. So I get 20 on the left side when I add it, and 20 on the right side, so yes, this does work out. So I would like for you to do the got it question by using Euler's formula to find the missing number. So on the first one, it wants you to find the faces. So what I did was I used Euler's number or Euler's formula and plugged in what I knew. So it's faces plus vertices, so I put 20 in there, has to equal edges plus 2, so I put the edges number in there. So then I just did some solving, combined those two and got 32, and then subtracted 20 so that it told me that my faces has to be 12. Now you might be able to do this all in your head, which is perfectly fine. I just wanted to show you this is what I would actually be figuring out in my head. So then on the next one, I plugged in 20 for the faces. I had 12 vertices, so I'm going to add those two together. I need to find my edges plus 2. So I get 32 equaling edges plus 2. So if I subtract 2, that means that my edges have to be 30. Okay, so on the next part is how do you verify if it's in 2 dimensions? So we did this a long time ago. It was actually the very first chapter we did in geometry. And what that is that you had to draw out a net. So if you remember, a net is where we cut along the edges and flatten it out on a piece of paper. So if I took the problem, the polyhedron that I had in problem 2, and I made that into a net, that means I would cut along this top and flatten it out along with cutting along this bottom. So I would have all of these rectangles connected together that you see here. So I would have 6 of those faces connected together. And then I would also have the top and the bottom face as a hexagon because that's what they are up there in the polyhedron. So you first want to draw that net so that you can see what it is. And when you're changing from 2-dimensionals to 3-dimensional, your vocab changes, but it's okay if you don't put in the right vocab because really all it is just making sure you have the correct formula. So you're still going to do faces plus vertices equaling edges plus, now this is going to change to a 1 because now I'm in 2-dimensional. If it's in 3-dimensional, that's where I would put in a 2. So that's really the only big change. You would need to count your faces. So the faces, I would still have 8 faces. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Vertices, though, that number is going to change because now I'm going to count where I have every intersection of a line. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So this number will change, and also your edges will change because now you're not, you're counting every single line that you see, as opposed to over here, you won't double count those, you would just count what you see up top. So here, if I count every single line I see, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So there is a little bit difference when it changes to 2-dimensional, and you want to make sure that vertices is every point that you have an intersection of 2 lines, and the edges is every line segment that you see. So now I can plug that into a 2-dimensional Euler's formula, and so my faces was 8, my vertice number was 22, my edges was 29, and then remember I'm doing plus 1 because I'm in 2-dimensional. So now I would check to see will these equal the same thing, and they end up doing, so that I have 30 on this side and then 30 on the other side. Okay, let's see if you can do that part on the next piece. So on the next one, it first wants you to verify using Euler's formula for the solid. So I did that on part A. I counted 6 faces, 12 edges, 8 vertices, so I added the faces and the vertices, added the edges plus 2, and I did get 14 on both sides. So yes, it does verify. Then on letter B, it wanted me to draw a net. So you would have 4 rectangles, 2 of which were a little skinnier than the other because this one right here is skinnier, but the other 2 are a little bit bigger. And then my bases, the top and bottom, are your trapezoids, so I just drew in a trapezoid on that first one. Then it wants me to verify Euler's formula for your two-dimensional net. So this is where you need to count all your faces, which would be the same. It'll be 6. Then all of the edges are all of the lines that you drew. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So you should be getting 19 edges. And then you also should be getting 14 vertices. So remember, that's where every point that you intersect a line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, then I'm going to put it into the Euler's formula for two dimensions. So I do faces plus vertices, 6 plus 14 equals edges plus 1 because I'm in two dimension. And then when I check that out, I do get 20 on both sides. Okay, a lot going on right there. The very last piece is doing a cross section. And the cross section is the intersection of a solid and a plane. So you can think of a cross section as a very thin slice of the solid. So I was trying to show you in this picture. Here's a triangular prism. If I were to take like a piece of paper and try and cut through that triangular prism, the cross section would be right here where the piece of paper and the prism would intersect. So that shape would be a triangle. So how you know the shape, it'll always be the same shape as what it's parallel to. So like I know it's parallel to the base, so I know it's going to be that same shape as the triangle. So down here we're just going to practice finding those cross sections. So here you have a cylinder being intersected with a plane. So the question would look like, what would your cross section look like? So I left the picture from the book so that you could see it. It's going to be just a rectangle, because if I were to flatten this out, I would still be a rectangle on that cylinder piece. Okay, see if you can find the cross sections on the next two. Okay, on the last two, if I put in a horizontal plane, so going this way through my solid, my cross section would be the same shape of what it's parallel to. So if I look at the base that it's parallel to, it would be a circle. It says if I put a vertical plane through here, what would that shape look like? Well, it would be parallel to this. This has more of like a trapezoid shape rather than a rectangle, so that's how I would put it, as a trapezoid versus a rectangle, because a rectangle would have opposite sides congruent. Okay, I know a lot going on in there, and also an interruption with a phone call, but for this first section, it's about vocab, it's about making sure you understand Euler's formula, and then the last piece, just making sure that you can understand what cross-section would be. So remember, for the cross-section, it's always going to be parallel to whatever that base is, or whatever that other piece might look like.